Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 10E. My name is Amog Dhamdere, and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome all of you to the 11th version of the International Congress on Information and Communication Technology, ICICT 2026. The 11th edition of this conference is being organized in a hybrid mode, and the physical event was held yesterday in London, and the virtual event is being held through Zoom from the 25th to the 27th of February in 2026. I hope all of you will enjoy the knowledgeable and interactive sessions we have planned ahead. In this particular session, we will be having 6 presentations, and each presenter will be given 12 minutes for their presentation and 3 minutes for questions and answers. And on the completion of 10 minutes, I will be raising a gentle reminder. There is another request to all the participants that all of you please stay connected with us until the closing remarks are given. And if you have any queries or updates, you can write it to me in the chat box. Now, before we begin, I would like to introduce our session chairs for today. So our session chair for today is Dr. Gitanjali R. Shinde. Dr. Gitanjali Shinde has an overall experience of 15 years in teaching. She is presently working as an associate professor and head in Department of Computer Engineering at Vishwakarma Institute of Information Technology in Pune, India. She has presented a research article in World Wireless Research Forum, WWRF, in Beijing, China. She has published more than 50 papers in national and international conferences and journals. She is also an author and editor of more than 10 books. I welcome you, ma'am, and I request you to give us your opening remarks.
Thank you for nice introduction, and thank you for inviting me for the as a session chair. So we can start with the session. Thank you.
I would now like to introduce our next session chair, Professor Madhya, I'm really sorry, Dr. Harvati Hashim. Dr. Harvati Hashim is an associate professor at the Faculty of Education in the University Kebangsaan in Malaysia and serves as at the Center for Innovation in Teaching and Learning. She is a specialist in technology-enhanced language learning with research focusing on the intersection of digital technology and language pedagogy. Her work contributes to innovative teaching practices and the effective integration of technology in language education. We welcome you, ma'am, and I request you to give us your opening remarks.
Thank you so much. Hello everyone. I hope to have a wonderful session after this fruitful session. Thank you.
Thank you so much, ma'am. Without any further ado, we can now start with our presentations for today. Our first presentation would be done by Felix Kabwe from the University of Zambia, and the title of the research paper is Enhancing Security in Digital Financial Services, an exploration of emerging technologies. Sir, I request you to kindly unmute yourself and start presenting.
All right, thank you so much. I've actually unmuted. I'm trying to share my presentation with you.
Sure, sir.
So you can just bear with me, yeah? Are you able to see my screen?
Yes, your screen is visible and you are audible as well, so you can start presenting.
Thank you so much. Let me just quickly get to... Sometimes you miss what you've already put in readiness. Okay, let me just do this. Okay. Yeah, good evening, everyone. Should I say, I'm saying good evening because I'm following the GMT, and I know that some are already in the evenings or in the morning. So wherever you are reaching us, I welcome you to this presentation. This presentation basically is focused on the cybersecurity, financial technology, and combining the ICT for the digital financial security, regulatory technology, and emerging technology. And as you may know, we are having a challenge with the financial digital services because of the crime. The technology progress is actually good, but it's coming with a lot of risks. So my introduction is to bring you to see that the transformation we are having in payments electronically comes with a number of things like savings, credit access, in our case in Zambia. There's also growth, which is driven by banks. When you look at the MNOs, the fintechs, financial technologies, and the security essential for sustaining financial inclusion. Why should we be discussing the digital financial services? This is key because the evolving of the technology and also the services, somehow they are clashing sometimes because of different interests. Some are scammers, some are trying to get services from technology. So Zambia's the digital financial services largely is experienced through, the MNOs like MTN. I don't know, you may have different service providers in different countries, but in Zambia, we have MTN, we've got Airtel, we've got Zamtel. So in these services, there's exchange of money. There's payment, electronic payment, which is actually becoming huge in a lot of services. Even on the government portals, for instance, we find that the MNOs are being used for the payment of the same to cover some sectors. So in terms of governance, Bank of Zambia has the Act, Data Protection Act, and the Cybersecurity Act, which is governing this space. Then there is an increase of the security situations, which I have just alluded to. So what are the common threats that we're experiencing? There's phishing. Basically, you find scammers trying to get to end users, asking for specific information. There's use of SMS so that they solicit for secret information or information which is personal for use to, to harm the electronic users. Then that is for the advantage. Sometimes they SIM swap, where one would have a SIM card and would pretend like he's another individual, or would get the number of another person so that they get assets of, innocent people. There is also malware for credential theft, data breaches, and man-in-the-middle attacks. So we've got human factors amplifying these vulnerabilities. A case is taken for the period of the COVID situation, when we experienced a number of fraud. If you remember this time, most people were indoors, so there was nothing like movements, but there was still activity online, and this is a time the scammers will utilize a lot in terms of on the DFS, digital financial services. They were attacking people on the same areas I mentioned, like the SIM swap, the SMS phishing. So for identification, we have what we call Zambia Information and Technology Authority, ICICT in short. This one plays a major role in the know your customer, so that a number of times people would get 10 SIM cards. But this has been zeroed in to ensure that if you get a SIM card, we know who you are. And ICICT has played a major role in this area. So in 2022, there was a SIM research to ensure that everyone who was on board on ICICT, on your customer, was linked to a specific SIM card, not just so many of the SIM cards. And there was an experience of the SIM takeovers before that, but because of this, it really helped to control this scourge. Then there is also the need for multi-factor authentication, because this reduces the challenge. You know, when people have to really identify who they are electronically, it becomes very difficult to do some of these schemes. So there's also an aspect of literacy to the end users, which is helping. Then I'm on the fifth slide. I'm looking at the emerging security technologies we have here in Zambia. There's the artificial intelligence and machine learning for real-time fraud analytics. It's biometric and passwordless authentication. Then we also have some challenges which could be addressed. You know, the high-risk challenges in the multi-factor authentication. So in short, in fact, in my thesis that I'm working on, this is a major thing that I'm looking at. And the multi-factor authentication is a key in this area. So we are actually exploring this area so much. Then there's a blockchain for integrity and traceability. There's also the technology of cloud and edge security hardening. Of course, we may not really be 100% there, but there's great progress in this area. Then there's also the zero trust architecture. Then there's the regulatory technology automation, which is actually coming up. Find that the central bank, Bank of Zambia, is pushing the institutions that are in this space to ensure that they comply with the regulations. And they also make use of the technology to make them comply. Like, for instance, the artificial intelligence to assist them comply with the regulations that and the act, the law that is present there. There is also the technology of the quantum cryptography, which is becoming quite useful. We haven't made a lot of progress in this area, but there are a lot of strides that are on the way. So the implementation priorities for this study, there's the deployment of artificial intelligence and machine learning models, and also the adoption of device-bound biometrics and passkeys, standardizing the phishing-resistant multi-factor authentication, the Strength Cloud Edge AIM, and the macro segmentation. Then there's the incrementary adoption of the zero trust. This technology is actually very, very important, because the end users have to resist to trust anybody on wherever they are. So basically, you have to insist who is requesting particular information until someone opens up, or they identify themselves and you know them. That is when you can open up perhaps to share information that will be there. Then there is also the integration of the RegTech for automated compliance, which I talked about, and the human-centered security through ongoing training. So capacity building in this area is quite essential. So to conclude my paper, I'm saying the digital financial services expansion requires robust security foundations. Secondly, the layered controls support resilience and trust, and collaboration among the regulators and banks, MNOs, and fintechs would be very, very important. What are we looking for in the future in terms of research? The evaluation of phishing-resistant multi-factor authentication in real use, exploring the federated edge learning for fraud detection, the study of the human-centered anti-smishing interventions, and also develop zero trust and RegTech implementation guides. Ladies and gentlemen, this is my presentation that I had for you today. Thank you very much. I'm open for questions and answers.
Thank you for
Nice
your presentation, sir.
Nice presentation. I would like to have a one quick question that what are the different parameters that going to take it for analyzing the platform security? Like suppose you are using the AI ML for your financial security. So which parameters you will take for the understanding that how your platform is better?
If you've noticed, actually, this is in the future research. It's something that we have not yet explored, but if you see for artificial intelligence, it's something that coming with its own tools for analysis that could be considered. I wouldn't say there's a lot of I'll have a lot of answers in this area, but it's an area which is open for study.
Okay, thank you.
Dr. Hashim, do you have any questions for our speaker?
All right, thank you. Just one quick questions. I think in your future research, you did mention about human behavior. If you could share, what specific behaviors are most strongly linked to the FS cyber risk?
Pardon me, if you can just come again.
In your future research, you mentions about human behavior, if I'm not mistaken just now. Could you share what specific behaviors are most strongly linked to the FS cyber risk?
Okay. You see, human behavior on both sides for the fraudster and the end user. For the fraudster, they actually relish on the behavior of the one they are attacking. Sometimes they will send some messages which they will not ignore. So they understand how a human being behaves, how they would respond, and they relish on that they send sinister information which makes people to review their identities or information that is very secretive they are not supposed to.
Right.
So
So high
on the part
tendency of
of the
trust in SMS, right?
yes, like SMS, it could be email, it could also be voice. These things are becoming very complicated now because of the evolution of technology. On the side of the end user who is responding now to the messages coming, you'll find that there's just too much of trusting anyone. Anyone asks you something, you are free to give anything that you have to say. Then you discover it's true. For instance, you could be on the street, then someone asks you, "May I use your phone so that I make a call?" That statement becomes extremely dangerous because you don't know that it could be a call that would actually end someone into murder, and then you become a prime suspect. So human behavior, both sides of the coin, has to
Right.
be looked at. Yeah,
All right. All right. Thank you. Thank you so much for sharing that. It's very interesting. Thank you.
you're welcome, and thank you.
Thank you so much, sir, for your insightful presentation. We now move on ahead with our second presentation for this session, which will be done by Matthew Stanley from the Colorado School of Mines in the United States of America. And the title of his research paper is Precision Grasping Poses with Pair-Free End-to-End Partial Supervised Mapping Method. Sir, I request you to kindly unmute yourself and start presenting.
Right. You can hear me fine?
Yes, we can hear you just fine.
Good. And there's that. Without further ado, all right. So my line of work is focusing on improving data-driven motion mapping methods. A lot of the issues that I find with them now is their reliance on really large data sets that require them to be labeled and pairwise. So for hand mapping, if I'm going to map my 5-finger hand to a 3-finger hand, there is usually a master-slave hierarchy. So one of the hands are going to be prioritized. the quality of labeling pairs between the 5 and 4 fingers can be a little ambiguous, but they have to be precise. Otherwise, you're not going to have your quality mapping. So the issue becomes, how are we going to get around this other than just creating these large data sets, needing a ton of man hours just to even begin creating them? My initial research into this had led me to looking into synergy-based solutions. Synergy for human body describes how we can look at muscle groups, sort of generalize their motion in order to study muscle groups better. Salvietti, who I primarily was looking at, had found 3 big axes that describe human motion for your hands, being sizing or pinching, spreading, and curling of your fingers. With this, we could use this subdomain for describing hands to map to any other hands. This was something that I had done, and you can see that when I go to graph something, curling on the fingers, it works very well. But this is limited, these 3 axes. If I try to do something more complicated, like grabbing a cone, you can see that trying to train it, I still get decent errors, but all that happens is that it's averaging the curling motion on all the other hands. So clearly, synergy alone isn't going to solve this problem. So what I proposed is an expanded end-to-end partial supervised mapping model. This is a machine learning model that leverages end-to-end mapping to extract grasping information from images and convert them into all hand structures. It uses a weight-shared convolutional encoder, meaning that this encoder is going to be trained for your 4-finger, 5-finger, 3-fingered hands, learning to extract the same thing to avoid a master-slave hierarchy. It has a joint encoder and decoder so that you can convert the known joints and the predicted joints back into a latent feature space for us to compare when we do the cross loss. And then we still have our traditional reconstruction loss, ensuring that the proper joint angle for the image that we give does get reconstructed. And then we still have a synergy-based regulation, trying to ensure that we get synergy patterns to appear inside our latent space. These sorts of patterns, being that we want them to be low dimensional, there needs to be a fairly linear relationship between these latent features and joints, and they need to be fairly sparse. The synergy features described by Salvietti typically only correspond to a few joints at a time. So we can apply a kernel loss function to our decoder in order to promote this sparse sort of mapping. And then by making it shallow, as shown on these 2 equations below the figure, we can almost get a one-to-one mapping between how synergy converts from joint angles, or how joint angles are converted into synergy, and how our decoder is going to take those synergy values back into joint space. The whole point with this is that because we are training one image at a time, the data sets can be non-paired when we want to train it. And then for testing purposes, we would keep them paired. So for each hand structure, for the training, we gave them a random string of poses that we wanted them to reach, mix them up, gave it to one hand, mix it up, gave it to the other hand. That way we could ensure that the data sets were different when we go to train it. We wanted to train it on 3 different data sets, one being the synergy-based ones described by Salvietti, make sure that we can preserve all those features. The next one, labeled the cone data set, contained all poses that were unique for a 3-fingered hand. This was our smallest hand, least descriptive. Meanwhile, there was the complete one, which contained poses that the 5-finger hand were unique, but they weren't necessarily unique with the 3-finger. In this example, the last column I have grasping a ball, which really doesn't look special compared to grabbing a cylinder with a 3-fingered hand. This came up to be pretty important when we came to validating everything. Here, I looked at the results against each data set. When trained on Synergy, we got same results as I showed at the start. Meanwhile, with the cone data set, you could see that we do have, between different hand structures, we get the same sort of poses that we wanted out. They came up with around the same error between Synergy and cone data set, a little lower, but we also saw significant decrease in standard deviation. The biggest thing was that because the 3-fingered was limited to not being able to achieve the complete data set, we see that this appears in the entire predictions, meaning that if we trained in the complete and it wasn't unique for all hand structures, you're no longer able to achieve the mappings that you desire. So looking at the 2 where we can actually get the good predictions, we didn't actually see a whole lot of difference between going from just the synergy-based approach to our expanded EPSA model when we looked at just synergy poses. So we know that we didn't lose anything when we used our method, but we do here see significant improvement when we look at both compared to the cone data set. And as you can see in the video now, we still preserve the positions that we wanted while still being able to predict the cone, inverse cone poses that we were hoping to get. Thank you. I have a list of my references should anyone want to look at them.
Thank you so much for your presentation, sir. I now ask our
Yeah.
session chairs if they have any questions.
Yeah, it was a nice presentation. I'm just interested to know about the details about data set and what are the pre-processing required for this.
So the processing that we use, or as I collected with a Connect camera, just using a depth field so that I could isolate the hands to get the joint angles I just read from the encoders. That way I could know that I had the correct pairing between one joint, or between one hand's joint angles and the image of that. Between the other ones, doing the pairwise for testing purposes, I assume that giving them the pose that I wanted to, they would be the same. So if I got the pose for grabbing the cylinder, I would give that cylinder to all the hands, then see if I could collect the images. Beyond that, there wasn't too much more processing that needed to be done.
Okay, thank you.
Dr. Hashim, any questions for our speaker?
No question from me. I'm just saying that this is a great presentations. Thank you so much for sharing. Very interesting.
Thank you.
Thank you for your presentation, sir. We now move on to our next speaker for today. So our next speaker is Priyansh Jaju from Clark University in the United States of America. And the title of the research paper is The Generalization Crisis and the Forensic Triad, a comprehensive survey of deepfake detection. So I request you to kindly unmute yourself and start presenting.
Hi, just let me share my slides.
Sure, sir.
Entire screen.
My screen is visible to you guys?
Yes, your screen is visible and you are audible as well, so you can start presenting.
Hi, greetings everyone. I am Priyansh Jajul. Today, I will present our survey on generalization crisis in the defect detection. This research was conducted with my team at UMBC and the Clark University to identify why current detection tools are failing in the real world. I will start by showing you the data behind the current crisis. Then I will explain why technology changed so quickly and introduce our solution, the forensic triad. Deepfakes are a massive financial risk. Fraud losses are expected to hit 40 billion by the next year, and current high-quality fake fools human most of the time, around 68% of the time, as we look at the research papers. We must move beyond the simple tools to more reliable forensic reasoning. We use a formula called generalization gap, which is whatever delta G, to measure how much detectors performance drop when it leaves the lab. As you can see in the chart, the legacy detectors work perfectly in the lab, but drop to 50% of the accuracy, which is no better than a coin flipping when face the modern deepfakes, the current times. As you can clearly see in the table 1, it shows the data for the specific models. The older artifacts model fail because they look for the pixel level patterns that no longer exist. Newer, fewer foundational models are much better, reaching nearly about the 91% of the accuracy. But they still cannot explain why they think the video is fake. As you can clearly see in this graph, it shows the arms race. In 2024, when new AI generators become popular, the old detectors are crashed. As you can clearly see that the blue line, when the phase one, it falls in 2024, as in it was mentioned the red in the graph in the red one, in the red circle, or the red square, you can say. They fail because they were hunting for the gen fingerprints that the modern AI doesn't leave behind. We are now in a recovery phase using the more advanced model. As you can clearly see in the phase two at the blue lines, the the accuracy got hit in the 2025. A simple real or a fake label is not enough for a courtroom or a newsroom. We propose a forensic triad attribution. Who made it? Localization. Why is the edit? Where is the edit? And the explanation why it is fake. We use the large AI models to help us understand why behind a fake. Even though our current models are accurate, they are still the black box. You can clear in the table 2, you can see It shows that the most models today cannot provide the explanation or a pinpoint the edit. Only the upcoming phase 3 models aim to answer all the three parts of the triad. Different industry needs different things. Social media needs speed, while legal cases need deep evidence. We suggest a triad defense, use fast math models to scan most of the content, but saves over most of the detailed forensic tools for the high stake cases. The newest research doesn't look for the digital noise, it looks for the violation of the physics and the biology. This includes checking for the natural breathing pattern and the consistent lighting. It is much harder for an attacker to fake the laws of the physics than it would do with the pixels, fake pixels. We are now moving away from the simple pattern of matching towards the logical reasoning. Our goal is clear. Forensic is no longer just about finding pixels. It is about verifying the reality. Thank you very much. I'm happy to take your questions now.
Thank you for your presentation, sir. I request our session chairs if they have any questions for you.
Thank you for the presentation. I would like to know that after this, before doing this survey, have you done any literature, that is, which type of surveys already done and what are the conclusions from that? And then after your survey, what is the future steps that you are going to take into your research?
So before that, we have read the 40 benchmark papers, which we divided into three phases: phase 1 and phase 2 and the phase 3. Phase 3 is for the future users. For the phase 1, as you can see, the detectors from the 2022 and before the 2022 2023 and at the starting of the 2024 before the new fix has arrived. So we have read the benchmark papers from year 2023 to 2025, which we split it into the two phases. And the third one that we are currently working on it, that we are calling the forensic triad, where we have to answer why why this thing is fake, why this video or the audio is fake. So we have read the 40 research paper for that, and all the papers are from the benchmark papers.
Okay, thank you.
Dr. Hashim, any questions for our presenter?
All right. Thank you for the presentation. Just getting a little bit of clarification here. What would an evaluation protocol that reflects reality look like?
Sorry, can you repeat the question, I guess, because there's a
Uh,
connection problem here.
just curious, and I wanted to know if what would an evaluation protocol that reflects reality look like? Like, what must be included? Is it unknown generators or mixed manipulations or etc.? If you could, if you don't mind sharing.
So as you can see, the defects has evolve in the times. As I mentioned in my slides, in the phase 1,
Mhm.
the detectors use the fingerprint method,
Mm.
where they have they have a detector and we can say identifier. So it leaves a fingerprint behind that, and after that,
Mm.
when we use the detector to detect the defect, it catches the fingerprint of it and it shows why it is fake. Like why it is can say why this video or audio is fake. It doesn't show any details of it, but it shows like why this thing is fake. It doesn't give any explanation of it, but show it is fake or not. That's the only thing.
Right.
And after in the phase 2, they evolve. They move from the detectors and they are just using the you can say in the phase 2 they are using something beyond the fingerprints. They doesn't leave behind any fingerprints. So it's kind of the high level defects, and even if we compressed it, it is easy for the phase 2 detectors to find the fakes.
Right. Okay, that's interesting. Thank you. Thank you so much.
Thank you for your presentation, sir. We now move on ahead to our next presentation for this session, which will be done by HDRR Vijay Singhe from the BCI campus in Sri Lanka. And the title of the research paper is toward cognitively grounded software complexity measurement, the C2M metric. Ma'am, I request you to kindly unmute yourself and start presenting.
Yeah, thank you, sir. All right, so I hope my presentation is visible to you.
Yes, it is visible. You can start.
Okay. All right. So, good evening, my dear panel members. I'm Dilsha Vijayasinghe from Sri Lanka. So today I'm here to discuss a fundamental challenge in software engineering, which is how we measure and what we build. So I'm going to use my study titled on Toward Cognitively Grounded Software Complexity Measurement, the C2M metric. To understand why this is more important, we must first look at a simple and fundamental truth, which is the software complexity is a primary barrier to quality attributes such as maintainability and reliability. As code bases grow in size and structure, our ability to measure them accurately has lagged. But having accurate complexity measurement becomes increasingly important for guiding design decisions and identifying maintenance risks as well as supporting quality assurance throughout the software lifecycle. So basically, the core philosophy of this study is that programs are written for machines to execute, but must be read and maintained by humans. While a machine processes a million lines of code without a second thought, a human developer has finite mental capacity. Therefore, through this study, my objective was to develop a metric that reflects a developer's true cognitive load, not just the machine's execution path. So, traditionally, the industry has relied on some traditional software complexity measures such as cyclomatic complexity. But this cyclomatic complexity suffers from structural blindness as it focuses exclusively on linear independent paths and treats every decision point as equal, regardless of where it is located in the code. And it also fails to penalize the mental stack required to track logics. For an example, it doesn't account the nesting depth of the code, as well as it doesn't oftenly overlook the try catch blocks, as well as it fails to measure the concurrency or the multi-threading. Therefore, there is a need of a metric that sees the code the way a human developer sees it. All right, so in order to address these significant gaps I mentioned earlier, I have designed C2M metric around 4 weighted pillars through this study. So the pillars that I have chosen are nesting level, which applies a linear penalty based on hierarchical depth, and also the basic control structure, basically assigning a cognitive weight based on the logic type. For an example, the cognitive weight of the sequences are assigned as 1, if cognitive weight of if then else are assigned as 2, and iterations are assigned as 3. And also, the try-catch blocks are assigned with a weight of 2, while multi-threading is assigned with a weight of 1. So in this slide, you can see the newly derived C2M metric. And as you see here, every single executable statement contributes to the total. So basically, this involved a process where it breaks down the code into some executable statements and then assigning the values based on the pillars. And then finally, it calculates the total here. So this process process acts as a complexity hotspot map. So instead of one single number for a whole program, we can look at a tabular calculation and see exactly which lines of code are draining developers' mental energy. So here is one of the example program that I have used to apply the C2M metric formula, and this is an example based on Java implementation of a conditional parity computation. So as you see here, the snippet involved with nested if statements, try catch blocks, as well as multi-threading. So if we measure using traditional complexity like cyclomatic complexity, this might be simple, the result might be simple, but if we when we are applying the C2M metric, according to the formula derived, it provides a score of 51, as you see in this table. So basically, as I mentioned earlier, according to the C2M metric, the program has been broken down into some executable statements, and then the weights are assigned based on the pillars, and then the total has been taken here. So by looking at the table, we can see exactly where the score spikes specifically in the nested thread declarations, and where the nesting level and concurrency weights are overlap. So also, in order to measure the validity of this C2M metric against this traditional software complexity measure, which is cyclomatic complexity, I have taken 10 diverse 10 diverse programs, and the programs are included with all the nested control structures, loops, switch cases, and when you look at the results, you might see the results were striking, because compared to cyclomatic complexity, the C2M metric has the mean complexity of 30.5, as well as if we comparatively see the magnitude variation, the magnitude variation of C2M is 8.7 times higher than CC, which means it depicts that the CC might ignore some penalty changes which are highly required to concern. So as a result, I'm going to discuss some of the results I have found. So according to this line graph here, it shows that the C2M varies much wider than CC, because as it concerns about the nested loop, switch cases, and other control flow structures. And here, as we see in the line chart graph, the CC changes more gradually because it primarily reflects about the decision points and does not account for any nesting depth or exception handling. So let me explain to you about the bar chart comparison of C2M and CC values based on the 10 programs I have taken. So when you look at this chart, we can see there is a higher the difference between C2M, there is a high difference between the values of C2M and CC. So all of these, so basically in program 2 and program C, we can see the difference is much greater because they might have some high control structures. So with all these results, it confirms that this cyclomatic complexity measure captures like it doesn't it doesn't scale more on the program, but C2M provide more discriminative representation of the complexity for modern software development. And as I mentioned earlier, this C2M was derived based on 3 main key areas. So through it concerns about the deep nesting. Actually, C2M recognizes that deep code is harder for a human to track, and exceptional handling was weighted, and it acknowledges the mental shift required to process alternative execution paths, as well as specific cognitive weight was applied on concurrency as well to reflect the difficulty of reasoning about simultaneous operations. So all these were identified through the results gained from the previous examples. And if I tell you why this study matters more and advantageous, mostly this C2M is a developer-centric formula, and it grounds measurement in the actual effort of the program comprehension. And also it is a paradigm independent because it works for all object-oriented functional or procedural code. And most importantly, it is maintenance predictive, as C2M scores identify the areas most likely to introduce bugs during future changes. And in order to conclude, conclude, I would suggest some future directions here. So basically, it is possible to work on automating this C2M through having IDE plugins for VS Code or IntelliJ, as well as the weights can be expanded to cover some other specific factors like asynchronous programming and lambda expressions, as well as so with all these, I believe that measuring code through a cognitive lens is possible to build software that is not just functional, but it is truly maintainable. So these are some of the references that I have used. With all these, I have come to the end of my presentation. Thank you very much for your attention and the time.
Thank you for your presentation, ma'am. I now request our session chairs if they have any questions for you.
Nice presentation. I would like to know about concurrency. How concurrency you have evaluated in the object-oriented programming using CM2?
Yes, ma'am. Could you please repeat the question?
Can you explain details about concurrency part?
Yes, concurrency is basically concurrency or the multiple threading is used here, basically concerned here. So if I go through this, let me go through things. So here the concurrency is concerned because it is very important for the mental effort required to track the parallel execution. So developers has to now if we think of the complexity of the program, the concurrency if the concurrency is not concerned, the complexity would not be accurate because as a specific weight has to be assigned for that, and also it ensures some of the complexity hotspots, like it shows it is one of the significant factor that has to be concerned. So here how it is concerned.
Okay, thank you.
Okay, thank you very much, ma'am.
Dr. Hashim, any questions for our speaker?
All right, thank you for the insightful presentation. I think you have done a good job on the practical contributions with C2M. If I may ask one questions, what would you recommend as a migration plan for organization already using CC?
Yes,
Maybe
ma'am.
as the way forward. Maybe as the way forward, what would you recommend as a migration plan for organization already using CC? Because now you're introducing C2M, right?
Yes. Yes, ma'am, because if we think about the CC, the traditional software complexity measures, actually it concerns only about the decision points, and it doesn't concern about any specific location or the factors based on the program. So it might give some inaccurate estimations at the end, and that would affect the whole program. But if we apply the C2M formula, it basically concerns about some of the control structures like the nesting depth and the exceptional handling. So there could be a big difference between the answers that you get through the C2M as well as CC. But in related to CC, applying C2M would be better because as it goes through the whole program and find out the most accurate answer. So, and in especially in future, like and also this C2M can be applied directly in the any lines of codes, because this is basically based on statistic analysis. So I hope that uh, this could be used to replace CC in future.
All right, that's great. Thank you so much. All right.
Thank you for your presentation, ma'am. We now move on to the last presentation for this session. The title of this presentation is Unsupervised Ensemble Learning for Real-Time Detection of Zero-Day Vulnerabilities and Dynamic Networks. And this particular research paper is going to be presented by all the co-authors. Their names are Akshat Bhandari, Jia Patel, Kashvi R, Varun U, and Geeta Dayalan. I request all of you to kindly unmute yourselves and start presenting. Just a small reminder, since four of you are presenting, I will be giving reminders for the time limit, but please keep an eye on the time limit. Thank you.
Perfect. Thank you so much for the introduction. Is my screen visible?
It's still loading. Yes, now it's visible.
Okay. Yes, thank you so much. So good evening, everybody. Our project is titled Unsupervised Ensemble Learning for Real-Time Detection of Zero-Day Vulnerabilities in Dynamic Networks. So I'm gonna let my co-author start off with what our problem statement is.
So, what are zero-day attacks? Zero-day threat is a cybersecurity attack that has never been seen before. So it's basically an attack that gives vendors 0 days to figure out a patch, and this could really affect like enterprise networks. Especially in 2024, around 44% of the attacks that were targeted to enterprise and network attacks were zero-day attacks. So what our model does is it uses an ensemble approach of an unsupervised ML model to flag the possible zero-day anomalies. And we are doing this by streaming this from multiple machines. So we're basically trying to replicate a small enterprise using Kafka onto a machine that's running the ML models for classification.
So now I'm going to talk about the architectural approach that we took. This is mainly divided into four components. First, we started with data pre-processing. So as mentioned here, we cleaned and normalized data sets like the TISSRC23, and we extracted numerical features for ML. So as you can see in the architecture diagram as well, it's in a flow where we used this data set to generate synthetic data, and this synthetic data as well as data from the data set was used to train and create a GAN that was going to synthesize data for our model training. So if you look at the second component, you have training our hybrid ensemble model, and the ensemble model here is three unsupervised models, which is isolation forest, local outlier factor, and elliptical envelope. We also have an attack classification model, which is in this case a supervised model random forest that was classifying every attack. And this was mainly the training phase, which was used to detect anomalies in the traffic as well as label what each traffic could be in terms of an attack. So, like mentioned here, it flags suspicious behavior. This data that is being streamed into our training model, we used Apache Kafka brokers to distribute the messages, and the consumers were fetching this information. And as you can see, the attack categories were we had DDoS, port scan, brute force, etc. That was all being used. That was all being labeled in our dashboard that you're going to see in our demo. And we were logging all of the the anomalous and the benign network logs in our dashboard so that people can view those logs as well as generate AI insights on the logs to get more information about the attack and how to mitigate it. Now we'll move on to the demo video.
Okay, so like my teammate said, this is our dashboard. So what's happening here is we're streaming the data from multiple systems onto one consumer. And you can see here that this is one of the systems. So I'm sending the packets from this system to our main system. And now what's happening here is that it's receiving all the data, and then this data is being passed through the model, all those three models, you can see that. And then once it's being detected as an anomaly, we have to classify it. So we classify it using random forest model. So here you can see that that it's continuously streaming. This is happening in real time. So we keep streaming it from multiple different devices. Yeah. So this is the graph of which attacks are being flagged. So you can see the first one is a DOS attack. There's a brute force attack. There's a brute force telnet attack, and then the second last one is a potential zero-day attack. So as they said that zero-day attack is something that we can't see coming, and so we can't actually classify something as a zero-day attack with 100% surety, but we can maybe say that okay, it has a potential to be a zero-day attack based on the features that it's seeing. So we have some 29 odd features that you can see. Then it's being classified based on that. So if you click on any of these anomalies, it'll give you all the packet information that's being sent to the model for it to detect it as an anomaly and then classify it based on this information. Now that you click on get insight, all these 29 features are sent to that one function, and once it's sent, you can see it's understanding of the features, and it's giving a reason as to why it's classifying that particular attack as one attack. Yeah, so I think we can move to the next slide. So this was just a comparison of various models that we tried. Initially, we wanted to take an RL approach, but we realized that since zero-day attacks are not something that are 100% sure, we do not have any reward to feed to our model. So initially, we started with deep QN model, and then we moved on to PPO. But when we were using the PPO model, it was overfitting immensely. Our accuracy was 99%. Then we thought of leaving RL and moving towards ensemble models. So initially we were trying isolation forest, SVM, and autoencoders, but the accuracy was a little less. So we played around with more models, and we finally came up with the three models that we are using now. That is isolation forest. Excuse me. So we finally came up with the three models that we have now. That is isolation forest, local outlier factor, and elliptical envelope. That is giving us a much better accuracy.
So talking about the results that we achieved here, our system got around a total of 87% of accuracy or precision of 87% too, and F1 score of 87. The real-time Kafka's consumer processing latency was around 0.3 seconds. The model was flagging almost around 45% of the network flows as anomalous. So, and with the Kafka thing is we can scale our models to multiple machines and make it as scalable as possible while achieving a good amount of processing latency. Can move on to the next one. So this is the dashboard of the detected attacks. So we have a potential 0-day column, but apart from that, this is the one that has been backmapped properly. So here we can see that the DDoS, SYN, brute force SSH, and brute force telnet are like, it's just a bar of how many attacks have been classified, while at the same time you see a potential of barely 6 to 10 attacks because as they are less. Can you move on?
So just to bring our project to a conclusion, what we tried to do is we implemented an autonomous cyber threat detection. So while most projects are doing batch processing, we tried to do it in real time, where we were streaming our data, doing the attack classification using our unsupervised ensemble model, and at the same time trying in a very small way to predict and mitigate 0-day vulnerabilities if possible. So this pipeline is continuously processing the network logs, detecting the anomalies, categorizing the attacks using the unsupervised ensemble model that we mentioned, and enabling detection of possible 0-day threats. And this is better because the unsupervised models are outperforming traditional signature based and supervised systems, and we're trying to validate that this approach is scalable, adaptive, and we also want to further go ahead and implement a self-learning capacity so that our model can probably integrate with industry standard softwares and be a more refreshing approach towards how we look at cybersecurity right now in different companies. So these are our references, the major papers that we went through to sort of aid our learning and aid our research as well. And that's all from us. Thank you so much. We're open to questions.
Thank you for your presentation, guys. I now ask our session chairs if they have any questions for you.
A nice presentation. I'm just interested to know about your data set and very first, what are the validation methods you have used and why you have stick only for random forest, not for other any ensemble methods.
Ma'am, yeah, thank you so much. So mainly, if you're asking about the data set, are you interested in understanding the features in the data set? Is that
Yeah,
what
yeah,
you're asking?
yeah.
Okay. Akshat, do you want to explain the data set, the features?
So in the data set that we've used, we had around 89 features and then we cut it down to 29 of them. We are using the most important features that could be used for any attack classification. So we have used the forward packets that are being sent, the backward packets, the IP addresses, the size of the packets, and etc. So we have used those. We have created a heat map of basically what could be the most important ones and handpicked them properly. And we are running it all on those itself. And more about the data set we had mostly had a lot of anomalous attacks, which could not be used because our model overfit for it. So uh, we use a synthetic data set using a GAN. We added a bit of noise to generate multiple examples so that they're not just flagged as anomalies, but even the ones that haven't been seen before.
Okay.
Are there any other questions?
Thank you.
Dr. Hashim, any questions for our speakers?
So far, no question. Thank you so much. All the best with the next steps and future development of this research. Thank you.
Thank you so much.
Thank you so much.
Okay, thank you, guys. That was a wonderful presentation. And that brings us to the end of this session. I now request our session chair, Dr. Geetanjali Shinde, to give us her closing remarks.
Thank you, Amog, and it was really nice presentations. I also learned a few new techniques through these presentations. I wish all the best to all the researchers for their next research, and thank you.
Thank you so much, ma'am. I now request our session chair, Dr. Harvati Hashim, for her closing remarks.
Thank you so much, Mr. Amok. I'd like to thank all presenters once again for sharing your research. It is very lively and interesting findings being shared here in this session. I hope everybody enjoy the conference, and I look forward to probably attending more sessions after this. Thank you.
Thank you so much, ma'am. I sincerely thank all of our authors for their excellent presentations and contributions towards this session, and all of our participants for being a part of this international conference as well. I hope this session was knowledgeable and interactive enough for all of us. And on behalf of the entire team, I would like to thank all of you for your support that you have shown in this 11th edition of ICICT 2026. We would be more than happy to host all of you once again for the 12th version in 2027. Just a small announcement for all the presenters. You would be getting your digital certificates via email within 2 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICICT 2026. I would also like to thank our session chairs for chairing this session. This is just a small token of appreciation for both of you. On behalf of Team ICICT and Global Knowledge Research Foundation, thank you, all of you, for your valuable presence. Just a small request before all of you leave. Can you please switch on your cameras for a quick snapshot of this virtual conference? Okay, I think we're done. Yeah, thank you so much, everyone. Stay safe and take care.
Thank you, sir.
You're very welcome, ma'am.
Thank you, everyone. Bye.
So much.
You're very welcome.
Thank you. Thank you very much.